For these ones, your goal is to write the expression as a single log. So we're going to use the same properties we did to expand, but we're going to kind of work them backwards. So for starters, you're going to look for any numbers that are in front of your logarithms that can be moved to become exponents. And that second one doesn't have one, so I'm just going to leave it. All right. And then I'm going to look to combine these two logs together. So since there's subtraction here, that means 8 to the 4th is going to be your numerator, 32 is going to be your denominator, and we'll have a single log base 2 out front. So I'm going to use my calculator to do 8 to the 4th over 32, because I cannot do that in my head. So 8 to the 4th over 32, so you get 128. So log base 2 of 128. And then anytime you have a base here that's a numerical base and there's a number after it and there's no variables, you always want to make sure and see if that's equivalent to anything. So if you have the ability to do the log base in your calculator, go ahead and do that. So log base 2 of 128 will give you 7. And as a reminder for our friends who don't have that ability, if you just have like a TI-83 where you can't change the base, then the way that you'll have to do this is type log of whatever's after the log divided by log of your base. So the 128 and then divide by the 2, and it should spit out the same answer. So again, that second part with the log 128 divided by log 2 is only for those of you that cannot change the base of your logarithm in your calculator. And so, as a reminder, the way you do that again is hit alpha and then the window button, and hopefully you have log base. It might not look exactly like this, but hopefully you have something that says log base in there. But anywho, log base 2 of 128, that's just equal to 7. Alright, and let's look at what's happening for the second one. Alright, so you guys love these ones. Log x to the 4th minus log, I'm going to go ahead and change that to x to the 1/3. Cube root is the same thing as saying x to the 1/3. And then since this is subtraction, I'm going to go ahead and put it together with division. From here, it becomes an exponent rules question, where to simplify x to the 4th over x to the 1/3, we're going to have to subtract 4 and 1/3. So 4 minus 1/3 gives us 11/3. So this is really just equal to log x to the 11/3. And the directions say express all powers as factors. So because this is a power and this is a single base, there's no other variables that are going on there, so I can go ahead and move that 11/3 out front. And our answer for that one is just going to be 11/3 log x. Check it in your calculator. Pick some random number for x. So yeah, let's see what x is right now. Great, that looks lovely. Our original equation was log x to the 4th. So log x to the 4th. Nope, that's not what I want. Minus log cube root of x. And then my final answer was 11/3 log x. Take the time to type it in to make sure it's equivalent. It's a really easy thing to do, and it could save you a lot of stress, potentially. Or at least it can make you feel good about yourself if you get it right. Alright, the last two in this section. For part C, first thing you want to do is see if you have any numbers to move. So this 4 can move to become the exponent on the y, and this 2 can move to become the exponent on the x. So we have log x plus 1 minus log y to the 4th plus log x squared. So whenever you have multiple logs, I would just go from left to right. So these two are going to get put together with division. So we'll have x plus 1 up top y to the 4th on the bottom with a single log out front. And then we still have this plus log x squared at the end. So the last step with this is going to be put these two logs together, and these two are going to go together because of this plus sign with multiplication. Now, the biggest mistake people make on this is they just put the x squared in the wrong spot. So remember, x squared, if you were to write it as a fraction, would be x squared over 1. So that should help you know that when you multiply these together, these become your numerator, and this becomes your denominator. So there's no reason to multiply out the x squared unless you really want to. I'm just going to leave it as x squared times x plus 1. The denominator is y to the 4th, and we need that single log out in front. And if you wanted to check this one, just plug in two different numbers, one for x, one for y, and go from there. Alright, the last one on here, we have a couple different numbers that need to get moved first. So we're going to move this 5 to become the exponent on the e, the 1/2 to become the exponent on the x, and this 2 to become the exponent on the x minus 1. So we have ln e to the 5th plus ln x to the 1/2 minus ln x minus 1 squared. So as we move from left to right, these two are going to get put together with multiplication. And we have this minus ln x minus 1 squared on the end. And now we're going to have to put these two logarithms together with division. So e to the 5th and x to the 1/2 go up top. X minus 1 squared goes on the bottom with the ln in front. This is kind of a weird one. You can leave it like that, or technically, if you wanted to, you could say ln e to the 5th times the square root of x over x minus 1 squared. That would work too. So either one, it's up to you. This one, remember e is a numerical value, so if you wanted to check this one by storing a value for x, go for it. Just make sure that when you see the e that you actually use the e button on your calculator to check it.